Is it only a coincidence that a metal born out of pure cosmic violence became a cause of violence and destruction throughout human history as well? Or is this the true nature of gold? Human fixation with this yellow metal has shaped the world. It fueled conquest. Armies were pulled across water, across land, into wars. Borders were redrawn. Continents were reshaped in its pursuit. Empires rose. Civilizations collapsed. Entire economic systems were built upon it. But long before gold shaped human history, millions, perhaps billions of light years away, it was shaped by pressure beyond imagination. The birth of gold was not gentle. It emerged from forces so extreme that even stars could not survive them. Gold feels ancient because it is. When we think of gold, we imagine Earth, veins hidden deep beneath mountains, rivers carrying golden dust, mines carved into stone. So we assume Earth made it, that it belongs here. But Earth did not create gold. No planet ever could. Planets are quiet places compared to what is required to form gold. Gold demands violence. It demands destruction. Forces so extreme that they occur rarely in the life of a galaxy. To understand gold, we must look far beyond our planet, into stars. Not the one holding us together, but the ones that lived and died long before our sun was born. Stars are builders, massive nuclear engines. At their cores, simple atoms are forced together, forming heavier ones and releasing energy. Hydrogen becomes helium. Helium becomes carbon. Carbon gives rise to oxygen, to neon, to silicon. This slow construction continues for millions of years until iron appears. Iron marks a boundary, a physical limit. Once iron dominates a star's core, fusion no longer releases energy. Instead, it consumes it. The result is catastrophic collapse under the star's own gravity. And still, no gold. This event creates many elements, but gold is not one of them. Gold is heavier than iron, much heavier. Creating gold requires something far more extreme than ordinary nuclear fusion. It needs overwhelming pressure. It needs a flood of neutrons so intense that matter itself becomes unstable. This process is known as the rapid neutron capture process, the R process. And it almost never happens. Almost. For most of cosmic history, such conditions did not exist, until stars began to die, in a very particular way. Most massive stars end their lives in explosions, but the very heaviest stars die differently. Instead of exploding, they collapse. Their cores compress so violently that protons and electrons are crushed together, forming neutrons. The result is a neutron star, an object of pure extremity. 10 to 20 times more mass than the Sun, compressed into a sphere barely 20 kilometers wide. A single teaspoon of neutron star material would weigh over 10 times more than Mount Everest. Gravity near a neutron star is so strong that space and time themselves are distorted. Matter exists there in a state beyond imagination. And sometimes, these stars are not alone. They exist in a binary star system. This may sound alien, but systems with more than one star are not rare. They're common. Our closest stellar neighbor, Alpha Centauri, is not a single sun, but 3. Alpha Centauri A, Alpha Centauri B, and far beyond them, Proxima Centauri. Even our own solar system once stood at the edge of becoming something similar. Jupiter, the giant among planets, grew dangerously close to ignition. For a brief moment in cosmic time, it hovered on the brink of becoming a star. But it failed. It never ignited nuclear fire, never burned. And because of that failure, Earth survived. Had Jupiter been only slightly more massive, our skies would have held two suns. Day and night would have changed, climate would have fractured, and life, if it existed at all, would have evolved under a far harsher sky. This possibility remains frozen in time, a reminder of how close we came. Elsewhere in the universe, binary stars do not fail. When massive stars in a binary star system collapse into neutron stars, locked together by gravity, they orbit for millions of years, closer, unavoidable, until the moment they collide, and the universe becomes violent beyond description. Shockwaves tear through space, temperatures rise into the trillions, neutrons flood outward in unimaginable numbers, matter is forced into new forms, gold is born, platinum, uranium, elements heavier than iron, forged not by creation, but by annihilation. For a long time, this idea was only theoretical. Then, in 2017, everything changed. Scientists detected gravitational waves from a neutron star collision, GW 170817, in the galaxy NGC 4993, within the constellation Hydra, about 130 million light-years from Earth. Telescopes observed the explosion, a kilonova that briefly outshone entire regions of its galaxy. The light revealed something extraordinary: heavy elements, including gold. For the first time, we witnessed gold being created in real time, producing an amount equivalent to several Earth masses. The theory was confirmed. This is where most gold comes from. Events like this occur roughly once every 100,000 years in a galaxy the size of the Milky Way. The closest confirmed binary neutron star system, PSRJ 0737-3039A/b, also known as the double pulsar, lies between 2,000 and 3,500 light-years from Earth, in the constellation Puppis, within the Milky Way galaxy. The two neutron stars are expected to merge in approximately 85 million years. In 2025, scientists confirmed that a smaller but significant amount of gold can also be produced by another rare cosmic event: magnetar flares. Magnetars are an extreme type of neutron star, possessing the strongest magnetic fields in the universe, hundreds to thousands of times stronger than ordinary neutron stars. During giant flares, magnetars eject neutron-rich material, capable of forming heavy elements through the R process, the same process triggered when neutron stars collide. These events can produce planet-scale quantities of gold. Magnetars are extraordinarily rare. Only about a dozen are known in the Milky Way. And giant flares that can create and disperse gold occur only once every few decades per galaxy. After gold is born, it begins its journey. Scattered into space, mixed with dust and debris. For millions, sometimes billions of years, it drifts through darkness. Eventually, gravity gathers it again, forming new stars, new planets, new systems. One such system became our own. Within that debris was gold. Every ring, every coin, every bar locked in a vault has travelled farther and longer than we can comprehend. Gold lay dormant for billions of years. When humans discovered it, we sensed something different. It did not rust. It did not fade. It endured. We didn't just admire gold. We assigned meaning to it. Power, divinity, immortality. Gods were cast from it. Kings wore it. Perhaps this obsession was not random. Perhaps it was inevitable. because of what it took to create it. Just like its cosmic origin, human history around gold became violent. Extraction, conquests, colonization. Gold claimed lives on Earth, just as its creation once did in space. To humans, gold is precious and rare. To the universe, it is nothing more than the silent echo of destruction. The fragments in your jewelry were once part of a neutron star, an object so dense that reality itself bent around it. We did not earn gold, we inherited it. And someday, when the sun dies and Earth is gone, gold will drift again, silent, timeless, waiting. Because gold was not born on Earth. It was forged in space.